Hi, I'm Michael, and welcome to Fun with Statistics. I'm going to be teaching you one statistical formula, which is called correlation. And my job is to teach it to someone who's never really had a lot of experience with statistics, so beginners are welcome. It's going to be as simple as possible. We're going to go super slowly, use lots of analogies, and hopefully you understand every step. But if not, just raise your hand. So I'm going to share my screen and we will move right into the program. So let's pop over to looking at what correlation is. In a simple phrase, it's the degree to which two variables are related. So co means two, and then relation means related. So it's simply how two things are related to each other. So here's an example of correlation. Salespeople who are higher in optimism sell more products. So optimism is correlated to the sales of products. And salespeople who are lower in optimism sell less products because they're not as optimistic, and that comes across, and people don't feel their enthusiasm and they don't buy as much. Now, one thing to be really clear about is correlation. Just because two things are correlated doesn't mean that one causes the other. So for example, if you look at this graph, the divorce rate in Maine, which is the red line from 2000 all the way to 2009, the divorce rate in Maine has pretty much gone down from 2000 to 2005 and then kind of steadied out from 2005 to 2009. However, interestingly enough, the per capita consumption of margarine is pretty much the same. Now, we pretty much know that there might be a correlation between consumption of margarine and the divorce rate in Maine, but one's not causing the other. This is actually what might be very well a coincidence. So we want to be careful to say something could be correlated, but we don't want to go so far as to say that one is causing the other. So again, just because two things are correlated doesn't mean that one is causing the other. But if you do see a high correlation, you could ask yourself, what else could be doing this? And there's lots of variables in the world, so there's lots of other things that could be happening. Now, correlation actually has a formula. It's a math formula. It's called the correlation coefficient, or Pearson's R. And here's what it looks like. It's pretty scary looking if you just look at it all at once. But really, this whole thing breaks down into simply adding, subtracting, multiplying, and then using the square root. And so we're going to be walking through step by step how to do a correlation. So the statistic itself is really trying to describe the relation between two variables on a range between +1 and -1. So let's say that something is perfectly correlated, that sunny days make people smile. And let's say that every time the sun is shining, everybody is smiling. So let's say that that happens to be true. Well, the correlation value would be a 1, meaning it's perfectly correlated, always happens. But you could have the opposite happening, where, for example, let's say that something goes up, in relationship, the other variable would go down. So let's say as my drinking and partying goes up at college, my grade point average goes down. So that's where you would have a -1. So as I party more, my GPA goes down. So they have an opposite effect. Now, if you want a +1, as I study more, my GPA goes up, and that could be a +1. And there could be numbers in between -1 and +1, and that measures the strength of the correlation. So what we're looking at is the correlations coming from what we call a bivariate distribution. Again, fancy words to say that we're basically comparing two things, two variables. And later in this lesson, we're going to be comparing a variable of a Vanguard mutual fund to see whether or not it correlates with the S&P 500. Does it move with those big stocks? Or does it move with the Nasdaq 500? Is it correlated to the Nasdaq 500, which are smaller, more volatile, riskier stocks that make more money, but they also lose more when things aren't going too well? So when we try to do a correlation analysis, we assign one variable as X and the other one as Y. Doesn't matter which one you do, as long as they're separate and stay separate. So for example, what is the relationship between height, we're going to label it X, and winning elections? We're going to label that Y. Some people have noticed that there's a correlation with the taller the candidate, the more likely they are to win. So here's how we would actually interpret Pearson's R, or the correlation coefficient. So the first one is there's a strength in the correlation. You get a number, and the number will tell you how strong it is. So how strong is the correlation? Meaning, how big is the distance from zero in either direction? If it's a really small correlation, it's close to zero. If it's a really big correlation, it could be closer to +1 or closer to -1. Now, the direction is what we call the direction of the effect. Is the correlation positive or negative? So if they move together, meaning the taller you are, the more likely you are to win an election, that would be a positive correlation. A negative correlation would be where something moves down when something else moves up. So the more I party at college, the lower my GPA. That would be a negative correlation. And then we move into how do we explain the relationship? What is the relationship between the two variables? What does it mean when we start to observe this? So the first thing that we can look at on the strength of the correlation is looking at what we call the absolute value, which is simply the number itself. So anything that is close to a 1, that's on the far end of the scale, that would be called a strong correlation. Strong positive correlation. If it's closer to the other side of the scale on -1, that will be called a strong negative correlation. That's the more I party, the lower my grades go. But if it's close to 0, that would be a very weak correlation. So that could be something like the more the sun shines, the higher my GPA. And when we try to do a correlation analysis, putting the formula into Excel, and we get a really low number like 0.05, the weather doesn't really mean much about what happens to my GPA. So here's a quick little guide to take a look at the variable. A small effect would be 0.1, and then a moderate effect would be, let's say, 0.3, and then a strong effect would be something like 0.5. And we'll be taking a look at some specific examples. So the 0.1, 0.3, 0.5 will be making some more sense to you. But you see the 0.1 is close to 0. The 0.5 is getting closer to that 1, but like 0.9 would be really big. So here's some examples. So let's say that we say that sunny election days is correlated to Democrats winning election, and the Pearson's R is 0.14. So that's basically saying you have a 0.14 relationship. Well, that's kind of close to 0. It's closer to 0 than it is to 1. So it's really not a very strong correlation. It's actually a rather weak correlation, which means sunny days and Democrats winning, probably can't make many conclusions about that. There's not much of a correlation there. So it would be called a small positive correlation between sunny election days and Democrats winning elections, such that the more often election days are sunny, the more often Democrats win that election. But probably the opposite might be stronger, that rainy days. So you would want to take a look at what rainy days would do. But 0.14 isn't a very big number. But let's take a look at car driving speed and your driving record score. Notice how it's a negative number, and it's kind of big. It's about a medium size. So what this means is that the faster you drive, the lower your driving record score as kept by the insurance company would go. So the way that we would interpret this one is that there's a moderate negative correlation. So as people drive faster, their record driving score drops. And now let's take a look at what we call effect direction. So the positive correlation, as one variable goes up, the other goes up. So this is kind of a review of what we just looked at. Negative correlation, as one goes up, the other goes down. Zero correlation, no relationship between the two variables. That sunny days in Saudi Arabia have nothing to do with how fast an orange grows in Florida. Not much of a relationship there. Now, this is what a positive correlation looks like. So this is the y-axis, the going up and down on the side, and here's the x-axis going left and right on the bottom. And if you draw a line in between the two, it's basically going up. So that means that as x increases, getting closer to 6, y goes up to 25. So you see the 6 is closer to the 25. And then we've got negative correlation. So notice how the little blue triangles are actually trending down, and we can draw a line between them. That's a negative correlation, which is basically saying that as the y-axis, 30 going down to 0, as y drops, x increases. So when you go from 30 down to 0, the x-axis goes closer to 6. And then we have a zero correlation, which means there's not much going on. So this is sunny days in Saudi Arabia and how fast an orange grows in Florida. Now, moving right along, let's talk about correlations and variable relations. So the correlation is going to indicate the degree to which two variables are related. Now, the variables are related in a linear fashion, meaning they follow a line, the lines that we saw on the slide before. We can actually use this linear relationship to predict scores on one variable from the other. So let's go back a slide and we'll take a look at this one. So let's say that this is my partying. So as my partying goes up, my GPA is going to be going down. So partying would be, let's say my number of partying days, let's say it would be 6 partying days out of the week. And this could be GPA. So as I party on more days, going up to 6 days per week, my GPA gets closer to 0. So this is where you can do the prediction, where you could say to someone, listen, the more you party, the lower your GPA is going to go. Or we could show the positive correlation where it's going up, where we say the more hours you spend in the library, the higher your GPA is going to go. So for an example, what's the relationship between time spent at the gym and your muscle mass? And could we predict how much time a person spends at the gym? Could that predict muscle size? So the idea here would be the more time someone spends in a gym, we're making some assumptions here that they're actually working out at the gym and not sitting in the sauna, that they would have bigger muscles. Might not be true because maybe they work at the gym and they're at the cash register. So this is why we say correlation doesn't mean causation. Now, let's try to do Pearson's R by hand. So here's the formula, super scary looking, but don't worry, we're going to do it hand by hand, but step by step. So what we're going to take a look at is Vanguard US Growth. Now, this is a mutual fund at Vanguard. This is actually a fund that I own, and this is the stock. This is the price of it going from November 27th from November 5th. So there were 16 trading days, and notice that the fund went from 163 up to 168. Okay, that's great. And then the Nasdaq, which are your smaller, riskier stocks, they tend to make more money, but tend to lose more money on the bad days. The Nasdaq on November 5th went from 11,890 up to 12,200. Great, it was a good week. What we want to see is what is the correlation between the Vanguard fund and the Nasdaq? So the Vanguard fund, we're now going to call that X because you have to assign one an X and one a Y. So the fund will be called X and the Nasdaq will be called Y. And then we're just going to simply start walking through the formula. So N is going to be the number of trading days. See the N here? That's number of data points. So there's actually 16 trading days. And then step 1 is to multiply column X by column Y, which is this, X times Y, X times Y. And now you get these huge numbers, but we used Excel. So that was pretty cool. And we'll show this live when I move over to Excel. So we're going to be looking at this twice. Now, the next one you do for step 2 in the formula is to square X. So that's X times X. So 168.45 times 168.45 equals this number here. And then we do Y squared. See that little up arrow? That means multiply it by itself. So Y multiplied by Y. Now Y squared just means multiply it by itself twice. So we could have Y to the third, which would be Y times Y times Y, but we just want Y squared, Y times Y. So 12,205.85 multiplied by itself equals this number. And then, so that's step 3. Step 4 is that we add up all the columns. And Excel is great for this. Now we're going to move into the formula again. So this is just a little snapshot of the last slide. So we already did all this math. Step 1 of multiplying X by Y, squaring X, squaring Y. These are our number of trading days. That's our N. This is the sum of all the columns. Now this E looking thing, sigma, that just means sum of. So this formula now is going to be put over here. So we're going to be multiplying the sum of xy, which is this number, okay? Then we're going to minus the sum of x times the sum of y. So that's this. So this whole line here is this, okay? So sum of xy is right there. Sum of xy, sigma, that big E is the sum of times xy. That's that number. Minus, there's the minus. Sum of x, that's this number here, 2591. Sum of x. Sum of y is, see the y? Add it all up to the 190,000 number, sum of y, okay? And then, so we multiply these two, minus, and this 100,202.328 is the top half of the equation. So that's this up here, okay? Now here's the key to doing these things by hand. Go slowly, go very, very slowly, and then it won't be too intimidating. Now the bottom half is this equation here, translated down here. So number of days, n, is 16. So see the n right there? And then sum of x squared, so that's the 419,000 number, that's right there, minus the sum of x squared, so minus sum of x squared, and we put that one in there. So that comes out to, whoops, let's pop this back. So now 16 times the 419,000 equals the 67 million. Then we minus the sum of x squared, the 671 number, and that comes with this comes in here. That's 2144.3855. So this number is everything in here in these parentheses. And then we're going to be doing n times the sum of y squared minus the sum of y squared. So there's the n, the 16. There's the 16, multiply the sum of y squared, okay, which is this number here, y squared, and this is the sum of the column right here. Pull it over. Here's the minus, there's the minus there. Sum of y squared, which is this big, big number, okay, minus the sum of y squared, so this is the 361 number. So 16 times the 225 big number equals 361, minus the 3613, and you come out with this number, okay? So now we're going to keep moving. So 2144, see how I put this box in here? That's this half of the equation. And then this box here is this part of the equation. 2144 times the 5303120 equals this big number that starts 113. Now we take the square root. That's with this little check sign with the big thing up top. And then we come up with 106,639.27. This is the bottom half of the equation. So remember, we had the top half up here, bottom half here, and we'll just put them together. So we'll bring it down here, bring this one down here, and we divide them, and you come up with 0.93. So what that means is that the Vanguard US Growth Fund is 93% correlated to the Nasdaq, or you could say 93% of its movement can be explained, or it moves step by step with the Nasdaq. So now we come into the question, does Vanguard move? So that's how we do it by hand. And again, we'll be doing it again, looking at the spreadsheet in Excel. Now we come up with another question. Does the Vanguard move with the S&P or the Nasdaq? Well, we know that Vanguard moves 93.9% with the Nasdaq, but what about the S&P? So when we go into Excel, we can do correlation on multiple variables. So Vanguard correlates with itself. So every day, the Vanguard fund compared to the Vanguard fund is always going to be 1. The S&P 500, which are the 500 largest stocks on the S&P. These are like your larger, more conservative companies. They're big. Again, the S&P 500 correlates 100% with itself. The Nasdaq correlates 100% with itself. And remember, by hand, we did the Vanguard fund 93.9%. So our by hand calculation actually matched what Excel did. So that's exciting. But look at the S&P 500. Vanguard fund is 64% correlated. Excuse me, Vanguard fund here is 41% correlated to the S&P 500. So it has a moderate correlation, but it has a large correlation to the Nasdaq. But what's interesting is the S&P 500 is 64% correlated to the Nasdaq itself. So when we watch the Nasdaq go up or down, we have a pretty good chance that the Vanguard fund is going to be going up or down on the same day. So how we would interpret this in English, the Pearson's R would be 94. So there's a very strong positive relationship, 0.94, between the movement of Vanguard US growth and the Nasdaq composite. So I'm going to stop sharing, and then I'm going to share my big screen so that we can go over and look at Excel. Okay, so here's our original data from November 5th through November 27th. Which we took a look at in the PowerPoint. And we're going to be looking at this again. So now, see this tab down here by hand? Let's calculate it by hand. So I pull the formula over. And step one is going to be X times Y. So this is just simply, as you can see, D times C. X times Y goes here. Step two is X times itself. 168.45 times itself goes over here. Step three is y squared, 12,205 times itself goes over here. And then we do this for each day. And then here in step four is the sum of all the columns. So this number is the sum of this, X. This 190 is the sum of the Nasdaq. And then these big numbers are the sum of this column, E, and then the sum of X squared. And then again, Pearson's R is here. So there's the R. And then we're going to be multiplying our same numbers. The sum of X times Y is the 307 minus the sum of X times the sum of Y. And so we multiply these two for the 492 number minus the 492 number. So here's the top half of the equation, the 100, 202. Now in this box, it's going to be this one. So the N is 16, which we got from over here. Sum of X squared is right there, minus sum of X squared. And then we're going to keep this in its box. So there's, we multiply it out and we get 2144. Then we do the bottom right of this equation. So 16 times y squared minus the sum of y squared comes out with the 530. So we just pull this number down here, pull this number down here, multiply it, take the square root. Now that's a formula. And the formula is right there, equals SQRT of N21, which is this cell number here, bottom half of the equation. Then we pull the top half number, the 100, pull it down, match it up with the bottom half, divide it, and we get 0.93. So that's how you do it by hand. A little messy, but you see it's really just a bunch of multiplication. So it's not too hard. However, what's really cool is you can actually take this data, and we have a function here in Excel where we go to data analysis, and this is where it does it all for you. So you go to correlation, you hit OK, and then you put in your input range, which is going to be the Vanguard fund, the S&P, and the Nasdaq. So you include all of them, and then we're telling this group by columns because the data is in column form. The labels are in the first row, which means the first row are our labels. And then you hit OK, and here comes our numbers. So again, with computers, it just makes it super simple. The upside is you get your data right, you get it fast. The downside is you're not able to do it by hand. So sometimes you don't really understand exactly what you're doing. So which is why I like to show how to do it by hand. So again, the Vanguard fund is correlated to itself 1-to-1. The S&P is correlated to itself 1-to-1, and the Nasdaq itself. But Vanguard US growth is only 41% correlated to the S&P 500, so it's a moderate correlation, but 93% correlated to the Nasdaq. So that's huge. So basically, one could conclude that the Vanguard US Growth Fund is highly correlated to the Nasdaq composite, which basically means that it's very close to being what we call an index fund, meaning that the Vanguard US Growth Fund is trying to replicate or imitate the Nasdaq composite. So that's how correlation works. Thank you for listening. If you have any questions, just raise your hand. Thanks a lot.